Hey everyone, welcome back to our channel. Today, we're diving into one of the most fascinating parts of our anatomy, joints. These incredible structures allow us to move, bend, and twist in ways that make the human body so unique. Whether it's a simple bend of your elbow or the complex movements of your knees, joints are at the heart of our mobility. So, let's take a closer look at how they work and why they're so essential for everyday movement. Let's get started. So what is a joint? A joint, also known as an articulation, is any place where adjacent bones or bone and cartilage come together to form a connection. Joints allow for movement, example are limb movement, and stability, example I skull bone stability. They can be classified based on structure, fibrous, cartilaginous, or synovial, and function, immobile, slightly movable, or freely movable. Let's see types of joints. Fibrous joints. Fibrous joints are where adjacent bones are strongly united by fibrous connective tissue. An example of fibrous joint is the membrane between the ulna and radius called interosseous. Cartilaginous joints. Cartilaginous joints are a type of joint where the bones are connected by cartilage. An example of a cartilaginous joint is the pubic symphysis. Synovial joints. Synovial joints are characterized by a synovial cavity filled with synovial fluid, which lubricates and nourishes the joint. An example of a synovial joint is the knee joint. Ball and socket joint. Ball and socket joints consist of a spherical head of one bone fitting into a cup-like depression of another bone. The shoulder joint is a classic example of a ball and socket joint. The head of the humerus forms the ball part of the joint, while the shallow, cup-shaped glenoid cavity of the scapula serves as the socket. Ball and socket. Hinge joints. Hinge joints allow movement primarily in one plane, like a door hinge, permitting only flexion and extension. The elbow joint is a hinge joint formed by the articulation of the humerus, upper arm bone, with the ulna and radius, forearm bones. It allows for movements like flexion and extension of the arm. Pivot joints. Pivot joints, also known as rotary joints, are a type of synovial joint in the human body that allow rotational movement around a central axis. The atlantoaxial joint between the first and second cervical vertebrae, C1 and C2, is a pivot joint. It allows for rotation of the head from side to side, such as when shaking the head no. Condyloid joints. In a condyloid joint, the articular surface of one bone is convex, while the other bone has a concave cavity. The radiocarpal joint in the wrist is a condyloid joint formed by the articulation of the radius and a row of carpal bones. This joint allows for flexion, extension, abduction, and adduction movements of the hand. Saddle joints. A saddle joint is a type of movable joint that allows movements on two planes, flexion or extension, and abduction or adduction. This joint is mainly formed between the bones, whose articulating surfaces have both concave and convex regions. The carpometacarpal joint of the thumb is a saddle joint, where the trapezium bone of the wrist articulates with the first metacarpal bone of the thumb. This joint allows for various movements. Gliding joints. A gliding joint is a type of synovial joint in the human body, characterized by the sliding or gliding movement of the articulating surfaces of bones. Intertarsal joints allow for subtle gliding movements between the tarsal bones. These movements contribute to the flexibility of the foot, facilitating actions such as walking, running, and balancing. Thanks for tuning in and exploring the amazing world of joints with me. I hope you now have a better understanding of how these vital structures keep our bodies moving. If you enjoyed this video, don't forget to like, subscribe, and hit that notification bell so you never miss out on more fascinating topics. Have any questions or thoughts? Drop them in the comments below. I'd love to hear from you. This is Shady signing off. Until then, keep learning and stay curious.